complex piece of software. I mean, come on, guys. You guys have had your headaches writing serializer.
Complex piece of software that's been around since as far as computers.
That doesn't make it easier.
And that was acquired by Microsoft. They bought this company. So the Word group and the PowerPoint group have nothing to do with each other. Even though the UIs look so similar, there's no common code base there. That's what I didn't know either when I went to Microsoft. I said, I'll go and make your Office collaborative. I already had done a project with OpenOffice, with an undergrad. And I said, we'll just go and make your Office collaborative. And then they said, are you kidding me? We can't change that code. We dare not touch it.
I guess that's why they came up with that.
Sorry?
I said, you're trying to make a collaborative office where the office guys don't even collaborate with each other.
Well, they can't. No. I mean, it's just that what is in California, PowerPoint was in California. And it was just a different company. And they could have had two choices. They could have made PowerPoint and Word not look like each other.
How did they make Office for Mac?
I don't know the whole story there, and and they always make sure the Mac Office is pretty watered down. At least I feel it's watered down. A lot of people say that's a feature. We don't have too many features there. That's good. But there's always behind, right? And they must have just re-implemented. It's not as maybe the PowerPoint company does it. Who knows? I don't know details. I wasn't interested in the Apple version. I was interested in the Microsoft version. I was interested in doing something. But that's what Google guys did then afterwards. They just said Google Docs. And what did Google Docs do? Google Docs don't have PowerPoint that's as powerful as PowerPoint. So so right now the feeling in collaborative systems is you can either get the nice single user features or you can get the nice collaborative features. You can't get both of them. Unless you could go and re-implement Office.
Why does Excel seem to have excellent collaborative features?
It's a simpler data structure. It's just a table. Look at how complicated this data structure is.
Yeah, because like Excel, you can have multiple people in there editing.
But it's so nice that
sync up,
you have these cells that demarcate things.
Yeah, it's true.
It's so easy to come up with a transaction. Like just the idea of a transaction is embedded in
There is
Excel.
no dynamic list array. What happened? The problem in Google Docs and Word is that there's this list. And when I insert a character at number 0 and you insert a character at number 5, my 5 has to become 6 to take into account the fact that you inserted at 0. In Excel, you don't have to worry about that. PowerPoint is easier. Okay, because again, if I add a slide, same issue. So anything that's dynamic is the issue.
But Excel is clearly marked. Each cell is.
You are appending or,
Collaborative Excel just boils down to a timing problem, like keeping track of everyone's different timings and making sure things resolve in a good way.
And Excel is often used for project reports. And that's nice. I go and enter my cell and you enter your cell and we just don't interfere with each other.
We did regression testing on the mobile app. And you would just save it and it would be like, oh, I brought some changes in from so-and-so who happened to be editing it at the same time as you. So an Excel document on a shared drive. It would just drive everything.
Okay,
Great.
RMI, boring, So how does RMI really work? Okay, so we've done when I say RMI here, I mean remote method invocation, not Java's remote method invocation. Okay, we've seen Java's RMI, and now we're looking at we saw Java serialization. Then we said let's look at the issues in design and implementation of serialization. So we looked at it in a very broad way. We looked at Gypsy, looked at IDL, looked at C. Similar thing I'd like to do with.
One question: RMI and RPC can be used interchangeably?
I use them, but RPC is more general. So RPC is something that C also implements, or C could implement.
What are the general differences between the two?
So method means on object.
Yeah, a procedure isn't necessarily a method.
All right.
Okay, that's the way I would do it. Okay?
But a method is just a procedure with an added argument. It's this object.
Okay. So I mean, everything is a Turing machine. Yeah.
Except it's not. It's discrete.
It's not. It's a finite machine with a lot of states.
That's right. Okay. So what's the big deal about RPC? Okay, we saw way back that if we have remote assignment, we can go and simulate remote procedure call using remote assignment, right? So we send expressions encoding methods and parameters. Okay, so I go and send this. I assign these to some variables there, and then we go and invoke a method. Okay, so in principle, if I just want to go and hand wave and say, what's the big deal? Everything else is detail, implementation detail.
That's the hell. Is details.
Right. Of course, the devil is in the details. The research is in the details also. Right. So, side effect of assignment is to call the method. So but at least we should, so we're going to look at this whole idea at multiple levels of abstraction, and this is the highest level of abstraction. Okay? So I'm coming from a distributed computing point of view, and I'm saying I know message passing, and this is what remote RPC is. Let's say I don't know anything about distributed computing. I'm just a 101 programmer. How would I define RPC to somebody who knows LPC, local procedure call, who knows compilers also? I mean, from an implementation point of view, fine, the method is invoked on the other end. But when a method is invoked locally, how would you define it? How would you explain what steps happen?
Okay, I think I might actually see that. When you get to it's like doing procedures in assembly. You have to copy your parameters into certain registers, and then you have to do a to a certain label, which is your procedure, and then you've got to read the parameters back out, and then you can do it, and then you jump back to where your program counter is.
Okay, that's good.
So it's like at the I guess
You-
at the biggest level.
you know,
it's kind of
I'm telling you, Rob, with GoTo and all that stuff, you are made for C.
I know, be careful. I feel like that is like the worst thing anyone can say.
No. You know, my progression through life is I was interested in physics, got interested in EE, got interested in digital electronics, got interested in architecture, did microprogramming, did assembly programming, and I'm doing user studies now. Right? So that is the way I understand things. I didn't go in lambda calculus and understand this all mathematically. Okay? I understood this all using that. So I have literally done microprogramming. I've taken switches and gone and programmed ROMs to go and make it all work. So this is, I have a lot of respect for anybody who can do that. Okay?
My 101 was in Java, so I'm going down.
Okay.
What do you mean? How would a 101 program? It's just that.
So it's not 101 program, a compiler guy. So he said go to, etc. But these registers, etc. being copied, where are the values being copied?
Well, so that's the thing. So when your compiler is going through your code, it comes up with these names, with these bindings.
Right.
Like at runtime, or
And at runtime, what does happen? What happens? He explained that at one level abstraction. Can you do it more concisely without go-tos, with using a better data structure than he talked about? What data structure are we talking about when we're doing all these go-tos?
one stack.
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 Okay, so what am I doing? When I make a method call, in terms of stack, what am I doing?
Pushing.
A what?
You're pushing a procedure call.
An activation record.
Yeah.
What?
An activation record. It's an activation. That's the.
It's like a little bit of stack memory and like your.
There's a record. There's some frame, right?
That this method was invoked.
A representation of the method call, because that when the method dies, you're going to pop the stack.
You're going to pop the stack, and that basically blocks the stack until the method returns. Right?
So the method call is translated into data structure, which is popped in the stack, pushed on the stack.
But you push on someone else's stack instead of your own.
That is RPC. Okay.
Okay, stop.
Full
Okay.
stop.
I don't think that's the way it works.
Okay. Just let's. Do you want to say I don't understand that way, or do you want to say that I understand that way completely, but it doesn't work that way?
No, it's, if an RMI, right, the whole point of that activation record is to block your own stack until, of course, that method returns, right? So when I'm doing RMI, I have a stub to an object,
Yeah.
and I call the method, and I have to block myself until that method returns.
Right.
So that activation record will not be pushed on my stack, but will rather be pushed on the stack, whatever thread is receiving the remote.
What did Derek say?
Me?
What?
No. Derek said that.
That's what I said.
What?
That a remote procedure call is you're pushing this activation record onto someone else's stack.
No, but I should be the one blocking, right?
But you can, because you can. Well, why not push a little one onto yours that says wait until I get.
There's still something that's got to be pushed on yours.
Well, of
So,
course,
like,
of
yeah,
course.
yeah.
But we're saying,
I'm
like,
not-
the remote part of the remote procedure call is essentially you pushing this down on someone else's
Yeah.
stack.
And the waiting part, that we are just saying, is the one that you're going to spend your next 2 weeks doing.
Oh.
Yeah, that little record that gets pushed on yours.
All that I'll do. You guys just do the waiting part. Okay, so it's and it's not that hard, but I'm just saying. So calling process, we have a stack which contains parameter, return value, return address, and other information. Okay, you make a call, you push on the stack, and now what's happening is that activation record is serialized into, marshaled into a message.
Difference between serialization and marshalling
Is, what did I just say?
I wrote it down. Serialization. Marshalling is serializing a method call into a message.
It's a special kind of serialization. Okay, which should all work magically if your serialization works correctly. Right? Okay, or there's some other issue. Okay, so we send this message across, and so then we get an activation record here, right? And that activation record gets popped, a message gets sent back. Right?
So what was that thing on top of the activation?
It was you're waiting on the return message.
Okay, if you're doing waiting. If you're not doing waiting, you can just pop that thing off immediately. So that's.
Then what happens to the return?
Well, if you're not waiting, you've got something that's sitting in another thread somewhere that as soon as it gets a notification that there's a message.
Something like a feature or something?
No, like a select event.
And then
Yeah, anyway, these are all questions that will be answered for you when you implement things. So I'm glad you have these questions because, the assignments are going to answer your curiosity. They're going to help you basically explore your curiosity. So,
Thank you for helping.
absolutely, that's my goal. I mean, come on, guys. If I'm not trying to help you, what am I doing? I mean, really?
Yeah.
Okay. So unmarshalling of call, translation of call, and so marshalling of call is translation of call between call and message, and unmarshalling is the other way around. Okay. So I'm just saying in text. So you're basically sending a message rather than pushing on the activation record. So let's go and see it at another level of abstraction now. Okay, so for this to all happen, we are assuming that there is some data communication channel established. Okay, let's not start from scratch. Which means server exports some external description of some data port, statically or dynamically. Okay, and the client goes in and makes it port connectable, and the client goes in, somehow knows the external description and connects to it. Okay, that stuff is taken care of by the remote assignment layer. Now, what other thing do we need in data setup, not the per call processing, but the setup processing? What else do we need in RPC?
We need a naming scheme
For
where we're wanting the call to actually end up.
So we need to go and say, these are the objects or these are the methods that can be called remotely. And maybe these are the names that can be used, some external naming scheme, right? So server exports some description of calls serviced on data ports, remote assignment nodes, okay? Statically or dynamically. And client finds that information and uses it during the call. Okay, so this is another level of abstraction we're talking about, getting down to the nitty-gritty a little bit. Okay. So let's go and see now a flowchart. You generate a call message for call using exported information. Okay, somehow you marshal things. And ultimately some operation has to be invoked here. Anything in between?
So you need at least a service running on the person receiving the Marshal call that has access to the naming scheme and can route the message to the proper area, and then something to invoke that, or to, yeah.
So somebody here to go and invoke this thing.
Right.
Somebody receive the message and invoke this operation. Anything else to be done here?
You need it. Where does it go back?
Okay, so let's just go in one direction first.
Oh, okay.
We'll go back in the next slide.
you marshal it down so you have a call.
You'll also have to serialize your arguments.
So that was done here.
Yeah.
Okay, but maybe let's go back what you're talking. So going back meaning what? What do you mean by going back?
So where the
Data
result
has to
is
go back?
because you know that you're on the communication channel, but it's possible that you're handling multiple different exchanges over
Right.
the same channel. So you need to know where.
So ready to go back, and in Gypsy you can just say reply,
Right.
and that's nice, or send to last sender or sender. Okay. Anything else this guy has to do before sending the message? This thing that you guys will be doing for the next 2 weeks.
So
So it has a block.
something there to go and some processing has to be done. Okay. So we'll just call it process call message. Okay. And it might go and decide, like in Gypsy, that you'll block for procedure calls, but you won't block. I mean, you'll block for function calls, but not procedure calls, or block for everything, or maybe block for nothing also is possible. Okay, potentially. So then we go and communicate call message or data port and handle any communication errors. Okay, somebody's going. That's your. You have to worry about these things. When you do RMI, you can get an RMI exception, right? So somewhere that kind of handling has to be done. That okay, my message never got through, and you have to. So this communication happens at both ends, and process call message. That it has to go and maybe do some massaging here also. Let's just be on the safe side. Put a processing here. We'll see what that might be. Okay, and so that's the thing. And in the return direction, you return a message. You return the value to call operation, and you can communicate return message to call a process. And again, you got to go and process here to unblock, or maybe something else might be done. So I'm just general algorithm that before we send the message, we might do some bookkeeping, and on the way back and on the way to and way back also. Okay, so that's another abstraction of what's happening. Okay. Okay. So we said that, look, this is the sequence of actions that has to happen. The method call gets transferred into this. And ultimately, there is the application at the calling site. There's an RP system at calling site, application at calling site, and RPC system at calling site. So what about the division of labor between these two?
So the first one would be the sort of marshalling. I guess the RPC system needs to do both the marshalling and any massaging of the data that needs to happen before it gets put on the wire, and then the app. Do we need to flip the RPC?
Maybe. Yeah.
Okay. Yeah. And then the RPC system at the calling.
I just copied this thing here. I didn't.
Selective processing, so processing and then massaging and sneaking off.
Okay, so that's the ideal system.
That would be nice.
That's one level. So there's two extremes possible. One is that the RPC system does as little work as possible, and the other is the RPC system does as much as possible. And you went and described the one that's as much as possible. And that's kind of unfortunate because you guys are implementing this. So you will just put some more work on in your plate. So RPC clients and servers handle all aspects of RPC. So that's one extreme, complete RPC awareness. Okay, and I'll show you an example, the Sun RPC, which was built for. So when I tell you guys that I did the first CRPC, I did the first transparent CRPC. Sun had come up with something called RPC that was completely aware, where the programmer did everything and they just did a few things. Okay, and I'll talk about that after we've talked about RMI. Okay, so, and the other thing is that RPC clients and servers are completely unaware of all RPC details, and the system takes care of it. Now, RMI, does it fall in this? Does it fall here?
Kind of, sort of. You have to at least handle the remote errors.
Okay, and I have to go and I have to register.
Yeah.
Okay, so.
Of course, you really can't be completely unaware.
Sure you can.
No, but how would you distinguish between remote and local stuff?
So let's imagine that I've programmed a JVM that when let's imagine I program a JVM that when I create an object, I create it somewhere else, and then my JVM is distributed. So the programmer knows nothing about how these objects may be communicating over.
But then you just took everything down into the OS level.
Yes.
Your OS
But
is
then the
by
programmer doesn't
default.
need to know jack.
Your OS is by default not distributed.
Yes.
But now you're dealing with multiple.
I didn't say this was a good idea.
Oh,
I said.
Do you think anybody would ever implement something like this?
It's like X Windows.
Cedar.
When you use
Xerox guys.
I'm sorry?
Xerox guys implemented something like this. I've actually used that system.
What's it called?
Cedar.
Cedar.
Yeah. Cedar.
The tree.
So Mesa was the first language, then they had Cedar as a successor to it. Mesa had strings, Cedar had ropes. So
That's petty.
That's all I remember from Cedar. They had a paper on Cedar, and I couldn't figure out how they were different from Mesa, but they got it published in IEEE Software Engineering. I remember that, and the only thing that I remember is that they had something called ropes. Okay, Gypsy supports a wider spectrum. To some degrees, it's closer to it's more transparent. It doesn't require you to have a remote interface, but it exposes a lot. So you also go and see the aware layers. Okay, and the question I pose is, can one have complete transparency, which you guys have already kind of answered, and I said we'll wait for this to much later. Okay, because right now I want to get as quickly to the synchronization parts that are relevant to your assignment as possible. Okay. So RPC versus RMI. Asad, RPC, OO or conventional, RMI, OO. That's what we'll use as our.
Or conventional.
Okay. So RMI is only O and RPC is broader.
Both of our calls should be asynchronous or synchronous.
So that's a separate issue. Okay. And that has to do with transparency. And O examples, we're going to take Java RMI, we're going to take Gypsy RMI, and Gypsy RMI is something we can play around with, so we'll use that for the detailed implementation. Okay. Now we've got a couple of minutes. Very quickly, what do you think is the difference between, from a design point of view? What have you seen as the difference between Gypsy and Java RMI? Having used both of them.
Because Gypsy defines the serializer factory and custom serializers for everything, it doesn't need to implement serializer, and hence it doesn't need to work only for remote things.
Well, Gypsy needs to implement a serializer. It just allows. If it's going to have RPC, it's better have some serializer. It can't tell the user to write it. It does come with something.
Yes.
Gypsy is more of a framework than it is like an actual Java RMI is sort of hard coded. You can't touch.
Okay, so one of the big differences is extendability.
Yeah, but Gypsy you can hot swap pretty much any module.
Right. But before you saw all that stuff, when you just used Gypsy RMI, you were just an end user, right? You didn't know what were the differences you saw as an end user.
It's very port based versus client server based, or it's not host based. It's more port based.
So ports, as an RMI user, you have to know about ports.
Yes.
That's one thing, right? And that's kind of related to the fact that it's all a framework also. Anything else that comes?
Why did RMI require things to be sent across the network to be remote? Why was that, and why?
No, hang on. RMI means remote.
Java RMI.
Yeah, means remote.
Everything that needs to be sent has to be every remote object needs to implement a remote.
And do you guys remember why it had that? It was a check for error handling. Error handling.
It forces handling remote exceptions.
And it also generates the proxy, I think. So if it extends remote, it has to generate the proxy.
No, that's the export object.
No, that's the export object.
Yeah.
That's the unified remote object.
Yeah,
So-
it seems
so-
like the interface.
So that's one difference.
Tag that
So we are going
the
to.
system used to say, oh, you need to have.
So how did
rows
Gypsy
remote
work
stuff.
without it? That's the main difference.
Okay, so I'm glad you're asking all these questions because you won't be completely bored in the next three or four lectures. So one difference we saw, and I'll just stop. One difference we saw was that the ports are very visible to you. Okay. Second difference we saw was that you don't have to have remote implemented. How it does it, maybe just some magic or whatever.
No, exactly. That's my question. How does Gypsy handle stuff that is normally handled by handling Java remote exceptions? Yes. How does Gypsy do that?
Gypsy, you can always catch the exception. You can always define remote and catch the exception. You are not required to. If you don't do it, then Gypsy will handle it for you. I'll tell you that a little bit. But at least it doesn't require remote, right? Somehow, whether it's good or bad is another issue.
Right.
Okay. So we'll continue with this next time. We'll talk about the basic design differences, and then we'll look at the implementation.
Has anyone ever?
Okay. Now something that, in case any one of you is still wanting this question answered for the assignment that's due today, this will help you to some degree. So I am allowing remote assignment and remote procedure calls on the same port, right? That means I have the messages going from the user on behalf of the user, and I have messages going on behalf of the user and messages going on behalf of the RPC system, back and forth. right? So how would I distinguish between these two kinds of messages?
You give it some better information.
Like some special bit string?
Yeah. So this is an assignment. This is a procedure call. Please serialize it as such.
So what did you guys do? Then you went in. So how did you specify this is a how would I specify the procedure call or a return value?
Give it its class name. So
Just use class names.
Give it a wrapper class for each one, and then the class name is the first thing that gets sent along.
Exactly. We have the serialization working underneath us. Just choose types that are defined by you. If they're defined by you, they have to be unique. Nobody else can define the type with the same name, and that type, and that's what you have to do in your synchronous receive assignment also, right? You have to go and pass some messages back and forth.
I thought if we delegate to the object port, we can just get objects straight out without having to do any of that.
No, but how do you distinguish acknowledgement for a? So your reply has to wait till the client, till the other end has gone in. Receive. So what's the receive semantics? Sorry, the receive has to wait for the message. Okay, so you guys don't need that, right?
Oh yeah, so we're just doing objects.
Yeah.
So
So what were all your questions about then? Oh, because you were doing send wait.
Well,
Yeah.
our problems from before was because if you don't delegate, you try to extend, then your own message received, because it registers itself as a listener, gives you a byte buffer for the message instead of an object. And we were trying to figure out how on earth we got an object.
Oh yeah, but we solved that problem.
Yeah, we solved it by delegation.
Yeah. Okay. So I guess you didn't have to face this problem. Okay. So how do you distinguish? Well, you just use special Gypsy types for messages. Okay. And Gypsy, your receive listener, will somehow trap these messages, and it'll say, okay, if it's my kind of message, I will do my kind of processing. Otherwise, I just give it to the user. Right. Okay, and of course you want to make this all extendable. Right? So so what do we have to do? We have to return we have to generate two kinds of messages: call and return value. Right? And Derek knows better than he wanted to know. So my RPC return value is a type, and what properties does it have? What do I want to, what are the various, so that's a type, okay?
Object, method.
So I'm just return value right now. The easy part first.
Return type.
Just return value, just an object, right? And I vacillated between making this a serializable or an object, and because I was vacillating, you had the problem on your Macs. Did you guys also have the problem that if it's...
It gives you an illegal argument. Because
So the bean doesn't say that, look, if one type is a super type of the other type, it's a similar property.
Because it wanted a serializable, and the only thing we could promise that we were giving it was an object.
Yeah, but okay. Then I have changed it after I tested it, I guess, maybe. Okay, because I didn't see that problem, and it was only when you mentioned that I saw the problem. Okay, here's the more interesting one, and this is what Derek knows more about, or this than he needs to. But what is my call going to be like?
It has a method that is often null, and it has an array of.
Okay, don't memorize. Just go ahead and try to think. I'm making a call. A call means
Method name, argument types, arguments.
an object also maybe?
Yeah, target object.
And method name is enough for overloaded methods?
No, that's why you also have the array of parameter type names.
Which he loves. Okay, so you need some unique way of identifying the method. Okay, and fortunately in Java, we can just assume use reflection capabilities to go and name that method. Okay, and again, I didn't know how general to be, and you can go berserk in these things. So what do you think my type parameter here is? I got a long name. Do I need a comment? So what's an object ID?
These are like some of the most generic.
No, object ID. What? Really?
An object, an ID type. Is it the system identity hash code? So is it a
Okay.
normal-
Firstly, let's look at context here. What are we doing? Describing a.
Method call.
Okay. When you call a method, what all do you need to go and pass to the other end? Okay. And
Object.
no. What do you say? Hang on. So what did you say?
The object.
Okay. How do you go and identify the object? I can't give it a reference.
Yeah, I mean, you have to start with the class name, and then you would need some kind of distributed reference.
How do you guys go and name an object in RMI?
We give it a name when we register it, or we don't, and then it registers with class name.
But ultimately, what is the ID?
The name.
Name. It's some ID, right? That ID is in RMI, the ID is a string. Does it have to be a string?
Wait, in general or in general?
In general.
No.
So, what would object ID type be?
String.
Or anything. That's my generic parameter.
Okay.
Okay?
But it's always string, right?
So
Yeah, I'm pretty certain of this one.
what's it?
I said, but in Gypsy it's always a string, right?
Some aspects are, it's all customizable, right? So I made it such that the default implementation uses string. Okay? But I allow somebody else to create another version where it could be, say, int or something else. Okay? And maybe this was too much, but, I just...
It lets you put another buzzword on the paper for sure anyway.
Which paper?
Well, if you're going to write a paper about Gypsy,
No, you
I
can't.
know you just did it.
You can't. Trust me, you can't write papers on abstractions. Okay?
It lets you put extensible.
Sorry?
If you were to, let you put extensible on it everywhere.
Say it'll help with things in the cloud.
No, I was just, yeah.
The thing is,
Yeah, I know. I mean, those are some, but that will go to a buzzword conference. So,
the object ID type, how do you force that type to also be the type of the keys that you have in that global hash map?
Oh, you'll get a, because you'll get
So-
an error if you don't. You'll get an exception.
so
No,
there's,
that's it. It needs to be forced somehow. You need to.
yeah. So you can go and instantiate those things with different types. You can elaborate those things with different types. So I can have one registry that takes strings and the other registry that takes. In fact, I think my registry itself,
Is templated? Is generic?
maybe, I don't remember, but it could be, right?
Yeah, that's it. That's what I was going to ask. Is the entire registry generic?
So what I did was I went very far with this generic idea, and then it gave me so many headaches and so many angle brackets that I said, you know what, I'm tired of it. So I looked at my notes, and apparently there's only one piece, one factory that depends on string. That's what my notes say, which is very good. Okay? But, I can't promise you. I really got tired at some point of all the angle brackets.
It's a lot of code.
Yeah. So my serializable call. So there's a call and there's a serializable call. My serializable call extends with a string parameter. Okay? And I can have some other serializable call that doesn't take the string. Okay? And basically, so we did it in two parts. We went and had method and object for sure. Then how are we going to describe the object and args we've got here. The method we're going to describe using this. Okay? That's another serializable call. That's another type. And
There you go. I was going to say, that's the one that has parameter type.
yeah. And then this one is going to is got this parameter type names. Okay? So that identifies. That identifies them.
Oh, method is transient?
Yeah, that's why I was
always now, right?
No.
I'm messing
It was
with-
always null because there was an off by one error in my bean serializer that ended up not putting parameter type names in there. The problem came when parameter types is null. You get a null for the method that got generated inside Gypsy. The problem is that there was a catch exception E return null, so I couldn't actually ever see the exception that got thrown. So I assumed that it
Did
was
you
happening
write that?
back.
Or was
No. It was buried in Gypsy somewhere, and I couldn't tell where it was actually generating the error from.
Bad exception.
No, you go and you go.
You didn't even print up the stat.
Now it does. I didn't imagine people would have off by one problems in their serializers.
But it was only when you had an object array followed by a more specific array type. It was a really weird scenario.
We try to
that
figure it
came
out.
up because of I literally had a plus in the wrong place.
Yeah, so I don't know why I didn't put the exception. there, and now it is there, you know. So in the one that I released, in fact, we went down. I said, really? I'm not giving you an exception there. So we went and tried to find the code when I do that, and it was not easy. We found the code, and I said, please go and tell me where the class is. I immediately went and put a print stack trace there, and it's there. Okay. So okay. So this has to be transient, though, right? You guys get that?
Yeah,
I can't just pass up a project. Okay.
but that was the thing that was confusing me. It was like, of course it's going to be null. Why would it not be?
Yeah, but then of course, if you had looked through the whole serializable structure and seen how did I debug with you, I would have said, let's look at everything, because I'd forgotten everything too. So
Yeah,
what about type names?
I couldn't figure out where it was actually trying to regenerate the method.
And then we ran it through Gypsy Serializer. We saw the type names were populated, so we figured that out. Didn't take us too long. Together.
Yeah, once I had someone who actually knew what was going on.
Okay. So so what now we can see what a marshaller has to do. Marshaller gets a Marshal call made on it. It said, please invoke this method on this object, on these args, on this object. And it goes and says, I'll return to you a serialized version of that call. Okay? And I say call rather than serializable call because this is where you can make it some other ID type also. So this is so marshaller is sort of, it's very concretely defined for you right now. Right?
So how does method get populated here?
From the other data type, transient, right? So there's enough information there. There's the object. There is the object class name. Object class name was also there somewhere.
There was a target object, and from it you could get the class name if you wanted to.
Okay.
But yeah, the client side has access to all of this. Like this is before it gets serialized, so it's trained. Like even though the method's transient, there's still a method that you can get your information from.
Oh, okay.
So there's a method at the caller end.
Right.
There's a method at the calling end. From the method at the caller end, which is going to be not transient, the serializable call gets created.
Okay.
That will have a non-null method in it. But because it is transient, that object will be sent to the other end. The other end will go and say, give me the method. Whenever it says get method, my object says, has the method been initialized? If it has been, it gives it that method. Otherwise, it goes and takes the surrounding environment. It takes the object ID, figures out from that the class. From the class, it figures out the type names and the method, and it extracts the method object through reflection and passes that object.
You can also generate a method from scratch with all the
Yeah.
information. That was what.
Right. So the first time I'll generate that. Next time you do get method, it'll just return the method it had done.
Okay.
Okay. And somewhere along those lines, it has to do a class for name, which is where we are getting in trouble here with Jinjing's code. Okay. Okay. Synchronization. That is the aspect that you guys have to deal with for the next 1 week. Okay. And let's understand this. So remember, we generate call message for call using exported information. Now we're going to go and process the call message at my local end. And do you guys remember what the processing of call message meant? I've generated the serializable call. What should I do after that?
On Marshal, when I go serialize that call.
So I can go and send that. That's what this is saying. Communicate that call on the data port. So this one generated the call. This one communicated the port. And before that, I have to do some action. Actually, I have to do 2 actions. Think about it. What if my call has an object that is not serializable? What am I going to do with that object? I'm making a call, and in that call is some value that is not serializable.
Don't our serializers throw an error if it gets something that's not serialized?
No, but just imagine that the call, your serializers.
You told us to. So
Right. See, I haven't told you everything, so I'm trying to lead you to a question because Gypsy doesn't rely on that. let's see. So I made a call.
So if it's not serializable, do you just pass it one of your pattern serializers and hope for the best?
Remember, I'm trying to get to the remote part. What if it's a remote object? Then I have to go and generate a proxy for it also. Okay. Remember, when you guys say registered and when you pass yourself, a proxy for you has to be sent. So things are not quite the way I described them earlier. We have to do something more than just send the object, the parameters in the form they were given to us. We don't.
Okay. So if the parameters are to a remote object, you have to sub in the proxy.
You have to do that. Okay, and maybe the Marshal is doing that, and maybe not in the process call. But we have to do some action like that, and I think that I'm assuming happens in this step. Okay, the Marshal does all of that stuff, and we'll actually look at that thing different. How do proxies get sent without having to generate proxies at the server end? That's what happens. But what else has to happen? And what was the keyword before? Synchronization. So can you see some synchronization step that has to happen here? If I'm a function call, somebody made a call, some thread made a call, I serialize that call into an object. What do I do with the caller?
Oh, you have to wait it. You have to tell it to wait until you've got a reply that you can.
That's a new verb, right, for computer science. Yeah, you have to make it block. Okay, that is the part that you guys have to deal with. And how are you going to make it block? You guys are just going to have a receive call. And if your receive works fine, you'll get the right value. Okay? And the receive value you will get now will be one of the messages that guys. I mean, it will be one of these internal RPC messages and not.
When we're implementing receive, we can just send back in for now, but we have to deal with that once we implement.
Yeah. Right now, your receive is anything because you're just writing a program to show receive. Yeah.
Because the send doesn't wait for the response.
Yeah, send's not waiting. Yeah. Okay. So this is the part that you have to deal with, and then when a message comes in, what is this processing going to do? Unblock. Okay. So you need a receive trapper, some work in the receive trapper. You need some work in the send trapper. The send trapper is going to go and, because the first thing I ask you guys to do is say, look, my procedure calls don't wait. You make your procedure calls wait, which means your procedure calls must do something different. And then I say, now that you know how to go and do wait, please replace my function waiting with your function, with your receive calls also. That's sort of the assignment. Okay? So these are the two things you have to do. And let me just tell you again some of the architecture here. So again, there are these trappers that you guys are getting into, which you didn't really need to get into. But
I don't remember needing a trapper.
no.
Yeah, that was a question I had.
Right.
Not for the receiver.
Okay. And again, I'm telling you all the details, but just to remind you guys that these trappers exist between ports. And how we went from the object to the byte buffer port, we put a couple of trappers there. This port does almost no work. The real work happens in these trappers here, one of which just forwards the object directly and the other one serializes the object. It is this trapper that went and called your serializer to go and send the object.
The forwarders are the trappers.
So the trapper can be either an adapter or a proxy. So I can have chains of trappers. Okay? Between any two ports, I can have either 0 or n trappers. Okay? So when you go and, by the way, the reason why you can't do subclassing of the overriding the notify method is because your trapper is the one that's notifying.
I know it's not.
Right? And if you didn't set a trapper, you'd be the one responsible for notifying. Okay? So there are these trappers that do the work, and between the object port and the buffer port are a couple of trappers. One is just forwarding, which you can replace with your own object, and the other is a translator, which you can also replace with your own object. But in general, I provide these two placeholders, and you can replace them, and when if you want. Okay. And similarly, between the RPC port and the object port will be trappers, right? Along the same principles?
The RPC port and the object port.
Because RPC port uses the object port to communicate the serialized call.
Correct, yes.
And where will the processing happen? In those trappers. Okay? And now these two trappers Do they have to have any shared state, the serializer trapper and the deserializer trapper?
Yeah.
What
Well,
shared?
they need to be using the same instance of the serializer because they're.
Do they?
Big house.
Oh no, I guess they don't.
The same factory.
Yeah, same factory. So yeah, okay, yes, they have to have the same factory, but they don't have the same instance of the serializer.
So no data structures.
Okay.
Will the trappers in the RPC case need to share some state? If they are synchronizing?
No.
I wouldn't ask the question if the answer was no.
Well, so
What is going to happen at the send end? I'm going to make the thread that's making the function call do
it
what?
has to wait. It's group on.
In some data structure? And who's going to unblock it?
Itself. Oh no, so the other one. So it's going to make a remote. I guess it makes a remote call just for the.
It just sends a data. It just sends data.
Right.
Then the data arrive along the received channel.
Yeah. And the receive channel unblocks the sending channel.
Okay, so you need some synchronizing data structures between these two trappers. Okay, that's the basic principle. I've told you guys pretty much what code to look at, and with this sort of high-level picture and that level of detail, you can do it all before Tuesday if you need to. Okay. All right.
How do you tell them not? If you want to. I think I accidentally did not.
No, but you'll need that for the next part. Something similar. You see that you can at least do your assignment due on Thursday. Okay, and I think I've given you enough context there that you, without even knowing how the whole thing is working, you can, change the.
What PowerPoint was this? Is this the Gypsy RPC PowerPoint?
Yeah. Lights are back, right? Okay, and we'll do that part, the one that you're supposed to change, and then we'll just see how much, what else I can do today and on Thursday, and maybe also after Thanksgiving. So what we saw was that there is an RPC port that finally goes and sends data to an object port. We know that. Object port, once it sends it to object port, your serializers take over. And you want to kind of know what is fed into the object port. And you guys saw last time what is fed also. You saw that serializable call gets fed and a return value gets taken out. And so we saw that certain objects that are created by Gypsy just get serialized through and sent by the object port. And we saw that things go between ports through trappers. There can be a chain of trappers in general. And when we went from object port to byte buffer port, the trappers did not talk to each other. They were just independent channels. But now these trappers talk to each other. They share some data structures. Okay? And why do they share data structures? For two reasons. One of which is if you're making a function call, or if you guys in your assignment have to make even a procedure call, we're going to make the sender wait. Okay? If the sender is going to wait, they're going to unwait or unblock only when a message comes in. Okay? So somehow they have to talk to each other for that reason. And do you guys know, for those of you who started implementing the next assignment, what exact data structure here, what object is the one that is used for synchronizing, that is shared between the two, and what's the class of the object? Call is what you send across, right? Serializable call is the object that gets sent across. We want to make sure that the serializable call waits till a return value comes in. So some object that is shared by the send trapper and the receive trapper is going to help with coordination, right?
Is that the RPC return value?
That's just the value that comes back. Return value comes back just as a new value. Yeah.
Talking about the coordinating.
Yeah.
Middle layer filter?
Sorry?
You're talking about the middle block. And then.
Yeah, I'm talking about something that is going to make this guy block. So something that can be used by this guy to block and by this guy to unblock the block guy.
Some form of blocking queue.
Yeah, there's a queue, right? And that queue is replaced by, in your system, by something else. You guys use receive calls now. And the object that's keeping the queue and that's going to go and do the receives, that object is which one? This receiver and sender both need to share it. So before you send, so after you send the call is not complete till it is unblocked.
Right, so a response has to happen.
Right. So the object that, it's just a name. I mean, I thought you might have said or what would you call the object that is going to block the sender?
Blocking queue, synchronization.
Send call completer. Okay. So it's actually, yeah, it's the other half, but it is kept by both the receiver and the sender. Right? So the send call completer is the one that can either go to a queue or go and do a receive or whatever. Okay. So that's the object. And so there's some coordination between, at the receiving side, at the calling side, there is some coordination between the send trapper and the receive trapper. And there has to be some coordination between the client and server also, right? That the expected format arrives, the return values that it expects is the return value that it sends. Okay, so there's coordination both between sender and receiver at the local side, and between the sender and receivers at the two sides. Okay, that the call that is sent from here is the one that is expected at the other end, and vice versa. Okay, so that's kind of stuff you saw. That well, you need to worry about both of these things in your current assignment. Okay, coordinating these two guys and coordinating the sender and receiver. Okay, and so the send call completer has many implementations. The duplex one has, and this is what. So what are these methods? Yeah. So what are these? What are each of these methods in the send call completer doing? So return value of remote method call is doing what? So somebody calls it. Who calls it?
The receiver, the caller.
The caller is going to call it after sending the serializable call. Is going to say, okay, let me call return value of method object, and is going to have some value returned. In the case of procedure, that will be just now. Okay, and what are these two methods then? So that's method. This is function. Sorry.
Analogous to the other different kinds of remote communications you can do.
Right. So a method call is either.
Function or procedure.
Okay, so we can control each separately, which is what happens in Gypsy. That we block here, we don't block here. Okay, so the remote method call is just going and dispatching it to one or the other. And this is what you guys have to worry about when you go and decide what you're going to do, how you're going to get the value back. So your implementation, like my implementation, is going to send a serializable call across. Okay, you're not mucking around with that. The question is what happens after the call is made. Okay, and you call this method, and you will. I think I asked you guys to do a different factory for a send call completer. Is that what I asked you to do?
Yes.
Okay, so that's what I do. And then what's this method going to be then?
That gets called by the callee.
By the, okay, this is very interesting. The callee or the receiver at the local end, right? At the local end, somebody has to unblock this guy, right? These two guys are blocking.
Yeah.
That's what I mean.
No. The blocking is done at the local end. Yes, this will get a message in response to something that happens at the remote end.
So the process return value is responsible for unblocking.
Yes. So at the sending end. Right?
But send call completer has all these interfaces, all these methods.
And send call completer is used by both the receive trapper and the send trapper.
And send trapper, right? But we have to make our own send call completer.
Yes, I think so.
Duplex send call completer. Right. Because duplex send call completer doesn't have all four methods. It only has two.
Oh, it must be inheriting otherwise.
What do you mean?
It's implementing this interface. It's got to have. Java won't let the duplex send call completer not have all four methods.
Deeper. No, seriously, I just made a class implements duplex send call completer, and the only unimplemented methods it forced me to have value of method, remote method call, and maybe process return value.
So the others are, okay, so you have to go in subclass. The others are, these are not all public methods then.
And they might be implemented higher up in the.
These are, so remote method call, guy goes and calls these two guys, so these are not, so this, I shouldn't say send call completer, okay?
Yeah.
I should say that this is,
Call completer is an interface. that
yeah.
doesn't-
So these, some of them are protected methods that are inherited. So I don't ask you guys to subclass of my,
No, you ask us to make our.
no, I think I say subclass.
Yeah, I think you changed it later to say subclass.
I did, right?
No, you said.
I said sub.
Provide an alternate implementation of this interface of duplex send call completer.
I know that, there's some qualifications.
That's derived from
Yeah. No, you're welcome to go and, do it all. You can just go and do the dispatching yourself too. I'm just saying inherit from me so that you just go and do this or the other. Maybe I should make it a public method. Maybe, maybe that would be beneficial. Because I also got confused. I thought I'd make them public. Okay? Okay. Okay, so basically the only, from the send trapper and the receive trapper point of view, the two important methods are this one and this one. These are the two methods. The process return value and,
Yeah, the first one.
because that's just dispatching.
Maybe process.
Okay, yeah, okay. So that's another, maybe process return value is basically saying that whatever you get could either be a return value or it could be a serializable call itself. So that's just a method that goes and checks whether what it got was a return value or not. So it returns true. Okay.
Yes.
Okay. So that's that. So I should really say here a duplex send call completer, and these are both public and non-public methods. Okay. Questions?
So the first three method is called by the sender, and then the sender block
Maybe blocks.
a maybe block. So the receiver called the process return value to send back a return value to the sender.
Yeah. Right. And actually, the receiver calls maybe process return value, okay, which does all the things about checking if it's a sent call, it's a received call, it's a received call or return value, and depending on which one of these it is, it goes and calls process return value. So it just says maybe process return value and maybe process value, and it sure calls process return value. So you don't have to worry about that dispatching. So the two dispatchings that happen, you don't have to worry about. One dispatching happens in the remote method call, because it may be one or the other, and the other dispatching happens when a return value comes in. When something comes in and you have to go and figure out whether it's a return value or a serializable call.
So the three we have to deal with are the bottom three in that interface.
Actually, you just have to, yes, absolutely. Which are not, the three you have to deal with are not in the interface.
Right, are in the interface. Okay, I got it.
So we just have to deal with the first and last one.
No. We don't have to deal with the first one because it dispatches. We have to deal with the bottom three because they don't dispatch. They actually do the blocking and unblocking.
Okay. Okay.
Why am I still seeing a mobile version of the handler in the last one? Can I keep refreshing but it keeps showing the same?
Clear cache.
Okay.
Clear cache. No.
So the procedure call, return value of remote procedure call, just non-blocking, simply returns in the current implementation, and this blocks a return value. Okay. Your implementation in the second part will make it block, but return just nothing. So this is the one that blocks. Okay.
It blocks and then when it gets the reply returns null.
Yeah, because a procedure call is just going to get an acknowledgement, right?
So alright, so I guess it's just you know for sure that it finished. Okay.
And for some reason, I just allowed an object to be returned there. Because the method invocation had an object. For some reason, I just didn't do a void there. Okay. So,
And on the previous slide, I think that doesn't that get executed in the selecting thread too?
so let's go and see all these things. Okay, this is going to be a very interesting issue. Okay, I hope you guys like this because I can't even tell you how much time I spent on this slide. And I'd like to create it automatically. So we'll talk about that in a second. So we have a remote object with some method that returns value t. Okay, Let's assume we've got now a function call. Okay. So we're going to call this method through a proxy. Okay. Somebody's going to call M on the proxy. Okay. What's the next step? What's the next step that's got to happen before we go to an object port, before we go to a send trapper? So we're going to ultimately, the message is going to go through the send trapper, right? A call was made in the proxy, an object has to be sent to the send trapper.
We have to serialize it first.
So we have to, the technical term, serialize it rather than, okay? So, and I put dashed lines here saying this doesn't happen directly. It happens through some intermediate objects that I'm not talking about right now, okay? So we get the object, and then we go and send it to the send trapper, okay? In whatever thread the proxy is executing. And what happens after this now? Send trapper gets it. What should it do next?
It gets into the next send trapper.
So it can, okay, so that whole chain and what else then? Finally, what will happen to it?
It'll get put in the send on port.
And it'll just go. Right? So send went and put it on the queue, and then what should send do after this?
Block off.
So remote function call is blocking. So it goes and says, through process, maybe process return value and so forth. It goes and says return value of remote function call. Sorry, through remote method call, it goes and says remote value of function call. Okay. And it's blocked. That thread is blocked. Not my selector thread. Okay, this guy went and put it in this queue. The selector thread went and got, read the queue. So these are two different threads we're talking about. You better not be executing your proxy call in the selector thread. Is that what the problem is? Is that the deadlock problem you had? Did you figure out what your deadlock problem was?
But I think it still happens. I think send call completer gets executed in the selector thread.
But if it'll get executed in the selector thread only if you made this call in the selector thread. You should not be making proxy calls in the selector thread. Remember the launcher has a create UI method and a post connect something method. Do post connect operations. Yes, sync operations. That is what happens in a separate thread. Otherwise, it will happen in the connection thread. Okay, so that is what you want to avoid. Sorry? Do post connect operations calls create UI. There's a method called do post connect operations. That is the one that calls create UI. Okay. Create UI doesn't seem to be a nice method name because you may or may not be creating UI. If you are creating UI, you do that. Otherwise, you do the longer name. That was my trick.
So does the launcher then make the current thread that's calling it the selecting thread? Or is that?
No. Launcher will create a new thread.
Okay.
After all the connects have happened, the launcher goes and then creates a thread to go and do post connect operations. Okay. Okay. Now this guy is going to go in my implementation. Go to a queue and just sync it. Not in your implementation. Right? Okay. Now the call goes to the other end. Through various things, it goes to the receive trapper. The receive trapper, what does it do? Or what should it do? You haven't worried about this so far. Or maybe you do have to worry in the second part, I think. Or even in the first part? Maybe.
You mean the receiving bucket?
Yeah.
It's the second part and the second part.
Yeah. So what should this guy do now? This is what has to be executed ultimately.
So it is it
So
Marshals to get it back.
so it's okay. So it's got to demarshal. What does demarshal really mean?
You deserialize the serializable call.
No, it's already been okay. So it's the object has been. It came as a byte buffer. It became a received call.
Okay.
So we've already deserialized it. Now we have to unmarshal it, right? We have to look at its fields
Create a method invocation for it and then input the method.
and invoke method, and hopefully, look at the type names, and if the method doesn't exist, not just return null. So that what should happen?
So it does. It figures out what the target object is,
and just calls
does
it.
reflection on it to get the method out of it, build the parameters, and grab the return type after the invocation, or grab the return object after the invocation.
And then what does it do with the return object?
Send it back.
Okay. Any threads involved here? Any new threads involved here?
I'm using the send, so that doesn't have to be another thread.
So we're going to invoke this method.
Well, we'll still have the selector thread on the receiving end so that more messages can come in while we're invoking this.
Is that just for throughput?
Well, yeah, and you don't want to go for this either. Because what if the method you call takes a long time to execute?
And then you're not responsive.
Exactly.
How long can it execute?
It can potentially go on forever if someone silly made an infinite loop.
So in your case, when you register this method, when you call register method, what does it do? It goes in, when you register, you go and send your proxy back. You send your proxy, right? And does it ever call back?
Oh, it can. I had this problem.
So to call back, it needs to select the selected thread needs to send the value. Selected thread is waiting. Okay, so if this guy goes and calls back, we'll see the deadlock
Oh, yeah,
situation.
because it'll call, like, if you pass it a remote object as a parameter and then tries to invoke some method on that, then it's deadlocked waiting on its send to go. Okay.
It's made this guy wait.
Yeah.
And so, okay, we'll see that. So, receive trapper goes and doesn't do the whole job itself. Just as there's a send call completer, there's a received call invoker. Okay, which is why you guys were getting confused. You were thinking if send call completer is the received call invoker at the remote side. No, these are two different objects. The received call invoker will go and get the message received. It's just a listener to that send trapper, and it's the one. And so receive will return after that. Okay, that thread returns, and now the received call invoker in another thread calls T at M. Okay,
We have to make our own receipt call invokers.
or subclass. Okay. And it returns, and what's it going to do? It's now going to go and do handle function return. So this is the thing. I go and have this method that you guys can then go and override, I think. Okay? So it'll do handle function return, which is going to do what? It's going to send a call to the send trapper and send a return value to the send trapper, and then the return value is going to come back here. Right? And it's going to go to the receive and the receive trapper, which is going to say maybe process return value or do something else or invoke the call. And it goes and calls process return value in the send call completer, which does a put. The selection thread is released. The other thread is released, complete.
Wait, the selecting thread shouldn't have been blocked there, should it?
No, that's release meaning it just goes.
Okay.
It does this next job.
All right.
What I mean is that this put is not a blocking function.
Right.
This is very important, by the way. Huh? This is a producer-consumer. This is a bounded buffer. Bounded buffers can make the producer and the consumer block. You better make sure that this guy never gets, the buffer is never full. Okay? If it is full, you don't. I mean, there's two ways to do it. So this happens in intra-processing in operating systems also. That if I'm receiving characters from the terminal driver, that when you do get C and put C, you are actually you are actually consuming. You are either a producer or a consumer. When you're doing put C, you're a producer. When you're doing get C, you're a consumer. It's okay for you guys to block, but the interrupt routine should never really block. Okay? We just have to hope that the buffers don't get full, and if they get full, you just drop the message and say, sorry, something bad happened, because I'm not going to make my selection thread block. Okay? Now you see why it took me so long to make this? Okay, firstly, these slides, these things, and secondly, how much detail to put in. There was a dash line here. I was putting more detail than was needed. I first didn't have, I had one version without the receive trapper. So by the way, you just have to take my word, right, that Gypsy works this way? And I have to,
what I've seen
it probably is right.
It works at least somewhat like this.
But wouldn't it be nice if I just wrote Gypsy and these slides would get generated automatically? Is that so crazy?
No, but they have help doc stuff that that automatically generate.
Can this slide be generated with help doc?
I mean, it might not be able to generate blocks, but it'll generate.
No, I want this slide. I want this graphical slide with these animations.
You want like a UML diagram?
I want this.
I mean, I don't know if it'll generate.
Don't give me what I don't want.
Visual Studio will do a two-way UML diagram for you.
Just because it has blocks and arrows doesn't mean that everything, just like saying, oh, you want this English sentence paragraph, I'll give you that English paragraph. I want this kind of this. You want this language.
You could get something like this, I think, but you'd have arrows all over the place.
Okay, then I need fill. How would I get something with too many arrows? How would I get that from Gypsy?
Because it depends. Like you have your marshalling calls, that or your the ones that call other functions depending on some some condition.
Right.
So you have to draw both of those arrows, and then so instead of it like sending from one, so like the sync call completer, instead of sending to return value of remote method call, it'll have to go to all three of them, and then so it'll loop back on itself.
So there's a system called Jive. It's very interesting. When I didn't know this problem, there was a guy who was a faculty member here who went to Stony Brook, and he was here for a conference, which I actually also, both of us had papers there. And he told me about a system called Jive, which actually tracks, it's a debugger that tracks method calls. And it can generate diagrams like this. So I ran Jive on an object editor. I waited for 1 week, it didn't return back, So it gets too many calls. But what I can do with my tracer bus, so I want to, and then with the filtering that I have in tracer bus, and if I can get an automatic layout tool to support this, I really hope to make that some summer when I can have the time, that I want to generate something like this. I've already found a way to go and write to PowerPoint from a program, so I can actually write to OpenOffice, and it has an API. And I can even just draw diagrams. So I really think that, I just waste too much time first coding and then writing this down. It would be nice. The layout will be the tricky part, but I've got a graph visualizer, and maybe you can tweak that to go and show something like this. But anyway, that would be good, because this takes forever. Okay, so that's the function call thing. For procedure calls, what happens? Proxy comes in, you invoke the Marshal call thing, you send, and then the call goes across, and then send says, well, I don't know, I'll just call return value of remote procedure call. And if you have overridden it, you can make it block. And if you haven't done it, that does nothing. It just returns, and then everything happens like before. The call comes in, and call gets called, and that's it. Okay, let's talk about deadlock. Okay, and I've got a different kind of diagram right now. So here comes a call at the server end. The selection thread goes and calls select to go and process the call, right? And that goes, and then it goes and says, okay, I'm off from the select. The same thread is now executing message received, right, in the RPC message receiver. And that goes and calls this method. This method goes and calls a proxy method back to the site. The call goes across, and this guy goes and waits for the return value. Okay? And that return value is not going to be processed till the selection thread unblocks. So it makes another select call. Okay. So you need another thread. Okay. And whether you get the thread or not depends on a factory. So one of the things I ask you to do in part 2 is to change the factory and create this deadlock situation to see whether it occurs or not. Okay. So return value comes in. Return value comes in from the other end, but there's nobody to receive it. Okay, so that's a deadlock situation.
Well, there is someone to receive it. He's just locked.
Yeah. There's no one ready to receive it. So there is an asynchronous invoker. There's a synchronous invoker and an asynchronous invoker. If you really know you're not going to do this thing, you don't want the context switching of threads, you can just put the factory and say, I want the synchronous guy. Otherwise, you can get the asynchronous invoker. Okay, so the asynchronous invoker, the call comes in, the selection thread calls select, message received, and I've got something wrong here. So message received should really go and I don't think I create the thread after this is called. Okay, I create the thread before. Okay, and I have to change this diagram. See, this is where you need my other system. So now the invoker will go and call. So I think I changed my design, and this may be a little older slide. And this will go and call the proxy method. So basically, the proxy method has to be called in a separate thread. That's the key, and I have to correct this diagram. Okay. And so it is this gypsy invoker that's blocking. What you could have done in your remote object is invoke this method in a thread. That is what I used to do before I added this thing. And I just went and used the same diagram, I think, to go and put gypsy invoker here. Okay, so that's something else you can do. If I'm not doing it, the system's not doing it. And by the way, do you guys know what happens in RMI when you make a call? You make 2 calls to a server object. Each call gets invoked in the same thread. So in here, there's only one invoker for all methods, incoming methods in gypsy. You could have a separate thread for each invoker. Okay, but there's only one thread. And I don't remember, and I forget whether RMI, is it the same thread or is it different threads? It's got to be a thread, or is it the selection? I'm pretty sure it is not, because you guys didn't deadlock. It's pretty sure they don't have an NIO implementation, so I don't even know what's happening there. Maybe so maybe each maybe there are multiple threads to receive messages also for all. Okay, but this is an important issue. That which method is invoking, which thread is invoking an incoming method. Okay. So factory determines if asynchronous method invoker is created or not. Okay, and that's the factory that I ask you guys to play around with. Okay, so I think I've covered everything you need for your next assignment. Questions? Should I have, in my calls and return values, should there have been some IDs there? Call ID, return value. I mean, should there be a call IDs there? And another way to ask this question is, how many such queues should I have? Or do I really need a queue, or can I have a little variable that you can wait on? Just a global variable. The last call. Just to be on the safe side.
So, you could argue that the target object, method, and parameters, if they're the same, then it should return the same value. So there's no need for an ID. But what if that function depends on some other factor that isn't encapsulated in that information?
No. So what would I do with the ID exactly? Tell me. So when I send my call, I said this is call number 10.
Right. And so when you send it,
you say this is return value for call number 10.
Right.
I mean, I cannot tell you how long I thought about doing this. It's so easy to do, right?
Yeah,
and I said, no, I want to reason this out. Do I really need it or not? And we might find out that I really needed it today. Okay? So just to be on the safe side, I could have sent it, but I really want to reason things out. Yeah.
It could get dangerous because if I think we'll sort of client. So the client calls to the server calls back to the client, then the client has to call back to the server, that could get dangerous.
It can, but
But each call would have its own ID.
Without the ID.
Well, yeah, that's what.
But you can alleviate that if you, right now in the assignment, we're waiting, the first thread that blocks is the first one to get unblocked, but if you do it in a stack fashion, it'll pop the return value from the other.
Yeah.
can a thread, so let's look at some invariants. Firstly, in RMI, they don't have this problem. Huh? From what Asad told us last time, or a long time ago, that you cannot have two outstanding calls to a server. Okay, you will wait till the first call completes, and then you will send another call. Okay, so they don't need an ID based on what we know of the semantics. Okay, here we are trying to be very, we are allowing multiple calls to happen. So there are two different. Okay, so how can you have? Let's talk of function. I mean, return values make no sense of procedures anyway, right? So let's talk of functions. Can there be more than one outstanding call, function call, from a client side to a server side?
Yeah.
In Gypsy?
Situation like you just said. So I would make a remote call on, I'm the server, the client makes a remote call on me, I make a call on the client, and then to serve that request, it makes a call on me.
Okay, so that's fine. So it has made two calls. Was the first call blocking?
Yes, because it needs to return value.
Okay, so how many different threads were involved here then?
Well, it depends on how you implemented your invoker.
So at the client end, there will be more than one thread, right?
There has to be.
Otherwise, you can't.
Right.
So a particular thread can have only one outstanding call, blocking call. We know that invariant, right? Now, if you have more than one thread here, can the return values come in the opposite order? You're saying they can?
Well,
so
if it's coming back, it's gonna.
That's it.
If your call from back from this, the final call to server, the second call returns, it's like popping off the stack. So if you give the return value to the last person that made the call, the last thread that made that call.
Yeah. So what happened? I made a call. Let's get this right. Maybe you guys are onto something, maybe not. So you called a method from here to the server.
Mm-hmm.
The server made a call back.
Right.
And you're a thread T, okay, and you are blocked here. That server made a call back here, which made a call again.
Yes, back to the server.
That's like basically two threads making calls here, right?
Yes, there are two threads, each making a call on the server. But the second thread that made the call needs its answer back first.
Right.
From that site.
Uh-huh.
Yeah, because it needs its request from the server, it gets to pop off, it sends its response back to the server, and then it sends its response back to the client.
So if you implement your return value queue.
Okay, so here's the deal, guys. Here's the deal. How many asynchronous method invokers do I have in Gypsy?
You've got one.
So what's going to happen?
Well, it depends.
The second call is not going to be able to be called, invoked, till my asynchronous invoker
It's free.
is free.
So you can't. So you have the same design constraint as RMI.
Not quite. I can have two different threads execute from here. Send them in parallel. They'll reach the server, but at the server end, they'll be serialized. In fact, all calls from all sites will be serialized at the server.
So it's not an asynchronous method. It's an asynchronous, meaning all method invocation happens in the separate thread, but those method invocations don't happen.
So I have only one of those. I don't have multiple ones. Sorry?
We need priority inheritance.
Well, this is not quite that issue here. It's not quite that. Right? There's no priority. I mean, there's no priority here, right? And you're saying somehow the return value should give higher priority. The ones that are sending a return value maybe should get No, what? I mean, what priority would you assign here? What would be the priority?
The later the method call, the higher the priority.
Really?
That you can't.
Do you really want that in general?
No,
It so happens here, in this example that works.
Yes.
In general, if you have two threads from the same site executing method calls, you want probably them to be occurred. Right?
Yeah, if you were, the only way you can solve the problem in general when only having one asynchronous method invoker is if you somehow manage to send along information about the entire call chain and how, like, if you could give it like a mini stack trace of all the different calls, then it can make a local decision on what the priority should be. So that's probably a bad idea.
Yeah, I mean, you could, what I could have done was have a per thread queue. I could have had a per thread queue and allowed multiple asynchronous invokers there. But my feeling was that if you want things to be, so I've got a constraint like RMI, except that I'm not stopping at this end, I'm stopping at the other end.
It manifests in the loop as well.
Yeah.
It gives you the same behavior, but for a different.
I do allow multiple methods. See, the thing is, it's not quite the same behavior because my procedure calls are not blocking. So I can send 500, you guys saw that performance. I can have multiple procedure calls being sent. They'll get queued up here, but I don't ever block. The procedure calls get queued up there, but there's no queuing and there's no queuing here for the completion. So this is the throughput is much faster here because I added the bottleneck at that end, at the server end rather than the client end.
So when things arrive at the asynchronous method invoker, does it have its own buffer that contains method calls that it has left to execute, and then just spawns a new thread?
No. Just one thread. There's the selector thread is the producer for that. It just keeps putting calls in there, and the asynchronous invoker just keeps receiving.
So the method invoker is on its own thread. The selecting thread is over here. It adds it to its queue and then returns back down, so it's free to get more stuff. This then invokes methods, waits for them to return, invokes the next method. Okay.
Goes back to the queue.
Right.
So you guys think that I should create a separate thread for each?
Well,
That's a lot of overhead,
it is a lot of overhead.
especially for procedure calls.
Well, you could solve that by having a thread pool.
Yeah, I can have a thread pool, but again, I was wondering whether you really don't you want some kind of serialization semantics? Okay, after all, there's a shared data structure in the server, and just figured that it should be accessed by one thread at a time. That was sort of my design.
If you had a thread pool, you'd solve our problem, but you wouldn't solve the problem in general. You could always come up with a problem big enough to make it.
If you have a thread pool, I have to have a separate, different mechanism at this end.
Yeah.
But the good news is we have factories, right? You don't like it, just change it, put another factory, and you don't have to change that much, right? So that's what I just decided to go in one way, and I said, okay, but I suppose the return value is something that could have had an ID to be just general. But I figured, why send this extra byte each time? Okay, so this is what I'm talking about here. Can I have a global received value? By the way, could I just have had one variable rather than a queue?
If you said I'm only going to allow one function call to be
Outstanding.
Outstanding at any given time.
If only one thread was allowed.
Yeah, if you say I'm going to receive any more method calls if I'm done returning this one, then yeah, sure.
But that's not what we want, right? So so we do allow multiple threads to be executing these things, and they will get the values in. So I could have just had a global variable and said clear and return received value, right? And multiple calls can be made concurrently to a server by different threads. Okay, so this wouldn't allow that. This should be a proceed. Okay, I could have just done that. And could I have had one bounded buffer for the whole port, client port, or server port? Can I just have one queue, or do you need multiple queues? So let's say I'm a client port or a server port. How many queues do I need given the constraints I have? I have given that the constraints that there's only one asynchronous thread. And one port. I realize different ports will have different queues.
Yeah, but I
Okay.
can't.
Okay, think client port, think server port. In the client port, how many queues do I need?
One.
In the server port,
You need one for each client.
one for each client. Because their threads are executing in parallel.
Yeah, but each client can only have one method call outstanding for any particular server.
So that's true. But it could be serving calls,
Right.
right? So return next value in global synchronized bounded buffer. We do know that calls return in the same order as they wait under my semantics. But so these, but that's at a particular callee. And so can we have global thing? Concurrent calls can be made to different callees. Okay. So we really need one bounded buffer queue per destination. That's what you guys see. Okay, per callee bounded buffer. And when you're sending the call, you just look up the destination and go and wait on that in that buffer, right? And when you process the return thing, you go and look up the source of the message, go to that queue, and go and put return value in the buffer. Okay, so it's a little bit more complicated that we have multiple bounded buffers. And at the server end is where the complication arises.
It's not that bad. It's the same semantics as when we did our blocking receives. We had to have a bounded queue for each
Destination. Yeah. That was supposed to match this so that you could transparently go and take your code and add it here. But you're right. Those semantics are pretty much the semantics that in any system that has received, they will have those semantics. In fact, what you've done in your receive implementation is basically, you can't wait for the slides to be posted, right?
I just want to make sure, because I'm going to start on this right after class, that I've got all these.
Whenever I give a talk at a conference, many times people are taking pictures. I say, I'll post you the slides. So, I'm totally off. What were we talking about?
Sorry. We're talking about how receive implementations mirror.
Yeah. So in fact, what your receive implementations mirror what really happens in an OS. Because what you think of as an asynchronous, the asynchronous message you guys get is very similar to the asynchronous interrupt that the operating system gets when a message comes in. And that asynchronous interrupt has to be transferred into a synchronous call. Okay, so that's pretty much what and you have nicer data structure, nicer language to deal with, but that's pretty much the logic you have to do. That's what socket receives are pretty much implemented. Okay. So my RPC return value does not have an ID for all these reasons, and I'm still not sure. I should ask Jim to help me prove the correctness of this. But I think I'd rather add an ID just to be on the safe side. But for now, that's the reasoning I went through. And I changed my mind many times.